Alright everyone, in this video we're going to be talking about, it's technically a mixed parallel series circuit, but there are what we call parallel packs present. So we have this 3-pack of resistors, we have a 2-pack here, and a 4-pack here. So these are all called parallel packs. And in order to analyze the circuit, first I'm going to show you the current actually. So current is flowing very slowly because of all this resistance we have in series with the battery. So if we were to up this voltage, we could probably get it to flow a bit better. You can see it flowing better now. Now, because these 3 resistors are all equal, these 2 resistors are equal, and these 4 are all equal, you should notice that the current splits evenly between these things. It's a 3-way split here, 2-way split here, and a 4-way split here. So one thing we can talk about is the current coming out of the battery is equal to the current going back into the battery. And let's just say for a second that that was 12 amps. 12 amps flowing out, 12 amps flowing in. We would then immediately know all kinds of information about this circuit. We would know that, well, here there's 12 amps because the 12 amps goes all the way around. It gets to here, it splits. But when it comes back out of that junction, it's 12 amps again altogether. It gets to here, that 12 amps splits into 6 and 6 because these are 2 equal paths. Then it goes back to 12. And then that 12 amps is going to split 3, 3, 3, 3. So each of these resistors will get 3 amps, gets back to the junction, and now you have 12 amps again flowing back to the battery. Okay, so I just wanted to illustrate that. We're still just dealing right now with how to find the overall resistance. So we're going to go ahead and do that now. All right, so this is the parallel pack number 1. I am going to actually just label these right now. We're going to call this one here, let's call this RA for pack A, RB for pack B, and RC for radio controlled, or in this case, resistor pack C. Okay, so 1 over RA is equal to 1 over 27 plus 1 over 27 plus 1 over 27. What you'll notice here is a little pattern is going to emerge. That's going to be 3 over 27. And when we inverse both sides, we get that RA is equal to, well, that's 27 over 3, which is equal to 9. So I'm going to give you a little secret here that 3 of the same, so 3 27s, in parallel, the overall resistance will be 1/3 of that, which will be 9. Let's see if the same thing happens with 2. Well, wait, we already know. We've seen this before. 2 50s are going to make it 25. So I'll show you the math for that. So 1 over RB is equal to 1 over 50 plus 1 over 50, and that's equal to 2 over 50. RB is equal to 50 over 2, which, like we said, is 25 ohms. So we're going to take a wild guess here and look at RC. Well, there's 1, 2, 3, 4 28s in parallel. So the overall resistance of RC should just be 1/4 of 28. So RC is equal to 28. Now you can only do this if they're all the same and they're in parallel. Okay, so RC is going to be 28 over 4, which is 7 ohms. Now to find the total resistance of this circuit, RT is going to be equal to, well, here's where students get confused. They say, well, do we use series? Do we use parallel? What's going on here? Well, what we're going to do is we're actually going to make it a series circuit. We're going to replace these 3 with RA, these 2 with RB, and these 4 with RC. So I guess what I should do here is, before even doing that, I should redraw this circuit. Okay, so I think I have enough room to do this right here. So I'm going to redraw the circuit. We got the battery. So we got 9 ohms here, that's RA. We got RB is 25 ohms. And we got RC is 7 ohms. There's our equivalent circuit right here. Okay, it's a simplified circuit, so now we can treat it as a series circuit, and then it works out a lot easier for us. So there's our series circuit. To find the total resistance of that crazy looking circuit, we're just going to say RT is equal to, well, in series we add them because the electrons have to go through each of them in order and hit all those resistances. So it's going to be 9 plus 25 plus 7. That gives us an answer of 41 ohms. So there's our total resistance for that circuit. All right. In another video, I am going to post a couple more things with this, like how to find individual voltage drops and things like that. But we got to learn a few other things first. All right.